everyone, I am Sneha, Assistant Professor, Department of ECE, Siddhartha Academy of Higher Education, deemed to be University. Now I am going to discuss about searching technique. So searching is a method of finding an element position from group of elements in data structure such as array, linked list, a tree or a graph. So this slide defines the concept of searching in computer science. It explains that searching is a process of locating the position of a specific element within a collection of data. It also mentions various data structures where searching is performed. So there are two types of searching: linear search and binary search. So this slide outlines the two main searching algorithms that will be discussed in the presentation. So the first search is a linear search, which means it is also called as a sequential search. It is a basic and simple search algorithm. This search starts at the beginning of the list and checks every element in the list. Linear search compares the element with all the other elements given in the list. If the element is matched, it returns the value of the index, else it returns 1. It returns -1. So this slide introduces a linear search algorithm. It explains that it's a straightforward approach that involves examining each element of a list sequentially until the target element is found or the entire list has been searched. So now how a linear search works. So now let us see the working of a linear search algorithm. So if you see on the screen, we have taken some random numbers 70, 40, 30, 11, 57, 41, 25, 14 and 52. So these are some 9 random numbers. So on the top of those numbers you can find the find some numbers from 0 to 8. 0 to 8 means total 9 numbers. So those 0 to 8 represent indexes of each number. Indexes means the position of that particular number. For example, here first number is 70. So first number index is 0, second number index will be 1, third will be 2, followed by other numbers. So any index of a given array, it will start with the number 0. The first index of any list of or of any array will be 0, not 1. That is an important point we have to remember. So among the random numbers taken, now I want to find out one number. For example, I am taking 41. I want to find out the number 41. So if you see in the list, 41 is in the index 5. Correct. So now linear search means, I have already explained in the previous slide what is the definition of a linear search. Sequential search. It is also called as a sequential search. Means you have to find out, you have to start comparing that 41 with each and every number starting from the beginning. Okay, so now I am taking some random number 41. So now 41 should be compared starting from the first number. For what is first number in index 0? The number is 70. So 41 and 70 are not matched. So you have to move to the next number. Next number is 40. Again not matched. Now move to the next number. What is next number in the index to 30? Not matched. Move to the next index 3. 11. Not matched. Then move to index 4. 57. Index 4 has 57. Again not matched. Move to index 5. Index 5 has a number 41. We also have chosen the number 41. So the number is found at index 0. So if any number is found, that index will be displayed at the output. Remember, the number in the index of the number in which we have chosen will only be displayed at the output, not the selected number. Index of the number will be displayed. If any of the selected number is not found in the given list, then output will be displayed as -1. Okay, this is about linear search. Now coming to binary search. So binary search is used for searching an element. This is also used for searching an element. Linear search and binary search both are used for searching an element, but the procedure is different. So it is used for searching an element in a sorted array. It is useful when there are large number of elements in an array. Particularly this binary search is used when there are large number of elements in an array. So these searching techniques look for a particular element by comparing the middlemost element of the collection. Now let us see an example. So let us see how a binary search works. Here we have again taken some random numbers 10, 12, 24, 29, 39, 40, 51, 56 and 69, and above those numbers you can again see some numbers from 0 to 8. 0 to 8 means total 9 numbers. So those 0 to 8 represents, here also it will have the same meaning like linear search. So those 0 to 8 represent indexes of those individual elements in which we have taken. So now I will consider some random number 56. You can consider any random number of your choice among the list. So now let the element to be searched is 56. Adjusting the search interval and finding the new middle element 51. So first of all we have to find the middle element here. So there are 9 numbers total. So middle element means it is a number 39 and it is found in the it is found in the index 4. So adjusting the search interval and finding the new middle element is 51. Comparing the new middle element with the target value 56. Adjusting the search interval and finding the new middle element is 56, and now the 56 we are getting the output as 56, and also the number we have chosen is 56. So both are matching. Now the element to search is found, so the algorithm will return the index of the element that is matched. Here also in binary search, index of the number found will be displayed at the output, but not the number itself. The number which is found, that index of that number will be displayed at the output, not the number. If any number is not found, then -1 will be returned at the output. Thank you.